In the last section, we talked about measures of central tendency. In other words, how we determine the middle of a data set. Now we're going to talk about measures of dispersion, which is how far apart the data are spread. So this first part should be labeled measures of dispersion. And dispersion, as I said, is just the degree to which the data are spread out. And we'll discuss 3 different types of dispersion, or measures of dispersion. They are the range, the standard deviation, and the variance. So the range is the easiest one to find because the range is just the difference between the largest and smallest data values. So we just take the largest data value, or the max, and subtract the smallest data value, or the min. So let's look at the following data set. We have 25, 37, 24, 40, 57, 59, 44, and 34. So first, let's figure out the min and the max data values. So the min, it looks like, is 24, the smallest. And it looks like the max is 59. So all we do is take 59 and subtract 24, and that gives us 35. You can use your calculator. So the range is computed using only 2 values. And since the calculation involves the largest and the smallest data values, the range is greatly affected by outliers. So the range is not resistant. Now let's talk about the standard deviation. So the formulas for the standard deviation are given in the table below. Notice population standard deviation uses the Greek letter sigma, and that one's actually a lowercase sigma. And the sample standard deviation just uses the little s. So just like with the mean, you have to know whether you're talking about a population or a sample, so you know whether to use the sigma or the s. So we're going to compute the standard deviation, assuming that this is a sample, by hand just once, because this is a math class and I want you to see how the math goes. After that, we'll never do this again by hand. We'll use technology. So don't panic if this is difficult. So if we look at the formula, what this says is we take a data value, subtract the mean, and then square the answer. And we do that for every single data value. And then we add all those up and divide by the sample size minus 1, and then take the square root of the whole thing. So first, let's figure out what the mean is. So the mean is 62 plus 88 plus 77 divided by 3, which gives us 62 plus 88 plus 77. That's 227 over 3, which is 75.7. We'll just round to 1 decimal place. Now let's compute the standard deviation. So first, let's do x1 minus x bar Yes, we should do this better. We should have x sub a. We'll just say a. That just means we're going to take each data value and subtract the mean. And we'll do that. We're going to do this as a table. So x1, x2, x3. Then we'll take that amount and square it. And that will help us. So let's see. We do 62 minus 75.7. I did not draw this table big enough for us to write anything in. And that equals, so 62 minus 75.7 is negative 13.7. Then we have 88 minus 75.7. Which is 12.3. And last we do 77 minus 75.7. And that equals, I believe, 1.3, but let's check my arithmetic. Yes, 1.3. Now let's take those numbers and square them. So we have negative 13.7 squared, which is, remember, it's very important you put that in parentheses. We need all our answers to be positive here. So that is approximately, let's say 187.7. We'll stick with 1 decimal place here. Then we need 12.3 squared. I don't need the parentheses when it's a positive number, but that's probably a little lazy. So 151.3, and then we need 1.3 squared. So 1.3 squared. So that's 1.7. Now we add all of those up. So I'm going to put a big old plus right here. And we get 187.7 plus 151.3 plus 1.7. Okay, so going to plug into our formula here, we get 340.7, which is what we got when we added up that column, divided by little n is our sample size, which is 3, and the formula says n minus 1, so 3 minus 1 means we have the square root of 340.7 divided by 2. So let's put that in the calculator. We're going to do second square root, and we want to make sure it takes the square root of this whole division problem. So we're going to put parentheses 340.7 divide by 2, and then close the parentheses. And then we can just hit enter. So we get S equals 13.05. We'll round to 2 decimal places. Okay, so we interpret the standard deviation as the typical deviation from the mean. So when comparing two populations, the larger the standard deviation, the greater the distribution has. And that's also true for samples. So the larger the standard deviation, the greater the dispersion. Okay, we'll talk about variance in the next video. Remember, don't panic about that standard deviation. We are never going to do it by hand again. We will be using the calculator, and I'll show you how to do that in a couple more videos.